Standard angles, degrees, and radians. I'm going to start by going through some terminology that you will need to understand in order to graph angles. An angle in standard position means that we take an angle and we place it on our XY plane. The beginning of the angle starts on the positive x-axis, and it's called our initial side. Where the angle ends, we name that ray the terminal side. If we look at this diagram below, we have an XY plane, and then we have an angle in standard position. This is our initial side, and this ray over here is our terminal. I'm also going to talk about quadrants because we will be discussing that throughout this lesson. Quadrant 1 is the top right, quadrant 2 is the top left, quadrant 3, the bottom left, and quadrant 4, the bottom right. You'll notice that we have an angle in standard position and two different measures of angle, a positive measure of angle and a negative measure of angle. The positive measure of angle is moving counterclockwise, and it measures from the initial side to the terminal side. If we put angles on our axis, that means that our initial side is starting at 0 degrees. The positive y will be 90 degrees. It makes a 90-degree angle. If we add another 90 degrees, we get 180 degrees. We add another 180 degrees, we have 270 degrees, and then one full rotation is 360 degrees. So that means that an angle in standard position that is 120 degrees must fall somewhere between our 90 degrees and our 180 degrees, and therefore be in the second quadrant. If we're rotating clockwise, we still start at 0 degrees, and then we would have negative 90, negative 180, negative 270, and negative 360 degrees. So our negative angles are the same numbers, they are in reverse order. It does not change how we name our quadrants. Now let's use this information to draw angles in standard position. In the first example, we have 300 degrees. It is positive, so that means that we are going to rotate counterclockwise. I'm going to start by putting the angles on our axis. 300 degrees falls between 270 and 360. I'm just going to eyeball this. We are not using a protractor. So that means that the terminal side is going to fall in the fourth quadrant. The initial side is always on that positive x-axis. Now I need an arrow to demonstrate which way the rotation is going. Because it's a positive angle, I'm going to start on my initial side and rotate counterclockwise and end on my terminal side, and then I'm going to label the angle. I'm going to do the same thing for 103. I'm going to start by putting my angles on. It's positive, so I know that I'm rotating counterclockwise. So I've placed my angles on there. Now I need to put 103. Again, I'm eyeballing this. 103 is closer to 90 than it is to 180, and it's also in the second quadrant. I have to draw my initial side and my terminal side, and then show the arrow in order to show the direction of the rotation, and then label. Now we're going to draw two angles that have negative degrees. So we'll start by putting our angles of rotation on the axis. Then we will draw the initial side and the terminal side. So negative 222 will be in the second quadrant. And then we show our rotation moving clockwise, and we put the measure of the angle on that rotation. For negative 440, well, that's greater than negative 360. So it looks like we have a full rotation. We have our initial side that we start with, and then we're moving clockwise because of that negative. So I'm going to do one full rotation first. After we rotate negative 360 degrees, we need to rotate another negative 80 degrees. Therefore, the terminal side will land in the fourth quadrant. And then we label negative 440 degrees. So notice that I show that rotation by going all the way around, which is the negative 360, and then another negative 80. Angles actually have more than one measurement. We are most commonly using degrees, but we're going to learn about radians today and the relationship between degrees and radians. So similar to a relationship between miles and kilometers or inches and feet where we can convert back and forth, we can do the same thing with degrees and radians. We're going to use the unit circle to identify the relationship between degrees and radians. Now imagine a unit circle is a circle that has a radius of 1 unit and there's a center at the origin. Here is my almost perfect circle, and I am showing the radius is equal to 1. Now what do we know about a circle? We know that one full rotation is 360 degrees. So let's pretend that we had this little dot that traveled along our unit circle. And as it travels along our unit circle, if we were to unwrap that unit circle, what would the distance be? The distance would be equivalent to the circumference of the circle. The circumference of a circle is 2 pi r. In our unit circle, r is represented by 1 unit, so we are going to simplify our circumference to 2 pi. We can use this information to make a relationship between degrees and radians. If our dot traveled around this circle, one rotation, that would be equal to 360 degrees. If our dot traveled around our circle and we measure that in radians, that's actually equivalent to 2 pi radians. Therefore, 360 degrees is equivalent to 2 pi radians. A simplification of this, if we are to divide both sides by 2, then that means that pi radians is equal to 180 degrees. So how do we use this information to convert back and forth between degrees and radians? Take a second and pause and write down the conversion between degrees and radians. Then we will apply this information in examples. We'll use the conversions to move between degrees and radians. Then we're going to draw the angle in standard form. So with the first question, we're given degrees, so that means we are going to change that to radians. To go from degrees to radians, we are going to multiply by pi over 180. Now we leave pi in the answer unless we're asked to convert it to a decimal. So we'll reduce 108 over 180. And that simplifies to be 3 pi over 5. We're going to draw our xy plane. We will put the angles on the axis. In order to do this, we need to know what 90 degrees, 180 degrees, 270 degrees, and 360 degrees are in radians. So each of those we need to multiply by pi over 180. When we multiply 90 by pi over 180, it reduces to pi over 2. When we multiply 180 times pi over 180, the 180s simplify to 1, so it equals pi. We multiply 270 by pi over 180, and we get 3 pi over 2. And our last one, which is what we identified in our conversion, is 2 pi. I'm going to place those on the axis. And then I'm going to draw my initial side and my terminal side. It does not have to be perfect. And my rotation and identify it, 3 pi over 5. Now, if you're wondering how I knew which quadrant it was, I just thought about 108 degrees. 108 degrees is in the second quadrant. Although I'm not labeling it as 108 degrees, I can just put it in the appropriate quadrant because I know it's equivalent to 3 pi over 5. In the second question, we're given radians and we want to convert to degrees. So I take 17 pi over 10 and I multiply it by 180 over pi. Sometimes I can't remember if I should be multiplying it by pi over 180 or 180 over pi. So one trick that I use to remember is I know that when I'm going from radians to degrees, I shouldn't have a pi symbol in my answer. So that means that I need one in the numerator and one in the denominator in order to cancel them out. Then I simplify the rest. 10 goes into 180 18 times, and then you can multiply 17 times 18, and we get 306. Then we're asked to graph in standard. Now our answer is in degrees, so that means I'm going to label my axis in degrees. And I'm going to draw my initial side and my terminal side and my rotation and label. The last question, 7 pi over 6. So I start by writing the initial question. I know that I need to cancel out that pi, and in order to do that, I need a pi in my denominator. So that's how I remember I'm going to multiply this by 180 over pi. Cancel the pi's and simplify what's left over. 6 goes into 180 30 times, and then when I multiply 7 times 30, we get 210. I'm going to draw my xy axis. My answer is in degrees and it's positive, so I label my axes, and 210 will be in the third quadrant. I draw my rotation that is counterclockwise and I label the angle.